Oh my god. That's awesome.
If you put two grapes in a microwave, they can create actual plasma, a completely different state of matter from solids, liquids, and gases. And this works in 4 steps. First, the microwave's wavelength changes when it enters the grape, leading to the microwaves getting stuck in the grapes. Next, an electric field forms in the gap between the grapes, and finally, that field makes plasma.
A household microwave operates at about 2.45 gigahertz, in air that corresponds to a wavelength of roughly 12 centimeters. However, inside a grape, things change significantly. Grapes are mostly water, and water at 2.45 gigahertz has a large complex permittivity, which you can think of as a high effective index of refraction for those microwaves. That shrinks the wavelength inside the grape by almost an order of magnitude down to about 1.2 centimeters, which is roughly the size of the grape itself. So when the physical size of an object is comparable to the wavelength inside it, the object can support Mie resonances, also called morphology-dependent resonances. So in simple terms, the grape behaves like a leaky spherical cavity resonator. The microwave builds up inside in specific standing wave patterns instead of just passing through or being absorbed uniformly. And because of the grape's size and index of refraction, the microwaves see the grape as the right size resonator, and energy starts to concentrate in particular regions inside the fruit.
The reason microwaves don't leave the system is to have total internal reflection. At the boundary between grape flesh and air, which have two highly contrasting indexes, waves striking at the interface at sufficiently large angles cannot refract out. If the angle exceeds a certain angle, the wave is totally internally reflected. Because the grape soaks up all of the microwaves, it becomes a trap for microwaves, which makes them go in a path inside of the grape. This path ends up making certain spots hotter.
When you put two grapes right next to each other in the microwave, they don't just heat up separately. The microwave fields can link up and act like one combined system. Because the grapes are similar, the microwaves can set up two main patterns. One pattern is where the fields in both grapes move together. The other pattern is where they move opposite. Like one is pushing while the other is pulling. The opposite pattern makes electric charge pile up near the spot where the grapes meet. And that creates a super strong electric field right there at the contact point. If the field gets strong enough, it can rip electrons from the air and from the skin of the grape. That turns the air into plasma, which is glowing charged gas. The plasma keeps absorbing microwave energy, so you can see the sparks or a bright glow. When scientists tested this with water-filled beads, they found similar results. This indicated to them that it's not just about the chemicals inside the grape, but it's about the water content and the size of the grape, as well as the grape's ability to concentrate the microwave energy between the two grapes.
This large electric field is large enough to rip electrons off of atoms in the air, ionizing it. When the air in the hotspot between the grapes is ionized, it makes plasma, which then touches the grape juice, vaporizing and ionizing that grape juice, making even more plasma. Once the plasma forms, it absorbs energy from the microwaves, keeping the plasma alive for a short time. And what is that plasma made of? Well, the scientists looked at the spectrum, or the pattern of light emitted, which shows peaks that match sodium and potassium. This is because grape juice has sodium and potassium, and when the atoms and ions in the plasma relax back down in terms of energy, they emit light at very specific wavelengths. Sodium gives off that main yellow light you see in the plasma, and potassium gives off light in the near-infrared in red, which is mainly invisible to the human eye.
When two grapes are placed close together, they act like a connected pair that concentrates energy into a tiny hotspot between them.
And that extreme field ionizes sodium and potassium to make a real glowing plasma. All of that from just two grapes in a microwave.
Waves operate at 2.45 gigahertz in air that gives a wavelength of about 2 centimeters inside a grape, mostly water high permittivity. The wave slows down, wavelength shrinks to about 1.2 centimeters. That's grape size. When size matches wavelengths, Mie resonance occurs. The grape acts as a leaky cavity resonator, so standing waves form and energy concentrates. That's plasma.